Today we are going to study the rate of change of quantities. Suppose we are given area A equal to pi r squared. It is area of circle. Now there are two possibilities. If area changes with time, then we find dA upon dt. And if area changes with the radius, then we find dA upon dr. Let's try to find them. So if we differentiate A with respect to t, so we write dA upon dt, then this will become pi and r will become r square will become 2r. Then we have to write dr upon dt. Now we try to find out change in A with respect to radius. So in that case, we write pi into 2r. We don't have to write dr by dr. Take another example. Suppose we are given volume of a cylinder pi r square h, and we let's take simple example, not this. Let's volume of sphere we consider 4 by 3 pi r cube. Here again, we can find change in volume with respect to time dv upon dt. In that case, it will be 4 by 3 pi into r cube will become 3r square times dr upon dt. Since volume is changing with the time, then r will also change with the time. But if we differentiate this with respect to r, in that case, we don't have to write dr by dr. So that is dv upon dr will be 4 by 3 pi times 3r square only. So this is difference. Now let's understand it by some questions. The volume of a cube is increasing at a rate of 9 cubic centimeter per second. How fast is the surface area increasing when the length of an edge is 10 centimeter? So volume of cube is given by, suppose edge is x, then it will be x cube, and surface area will be given by 6x square. Here, a rate of change with the time is given. It means dv upon dt. So it will become 3x square dx by dt. Here in our question, the rate of change of volume is given as 9. So what we put 9 equal to 3x square dx by dt. And we keep it here. Now we try differentiating this. So now ds upon dt will give 6 into 2x dx upon dt. We have to find out ds upon dt. From here, we can get dx upon dt. So dx upon dt will be equal to 9 upon 3x square. We can put this value here. So 6 to the 12x into 9 upon 3x square. Here in our question, edge, that is x equal to 10 centimeter is given. So we can put this value. So it will be 12 into 9 divided by 3 into 10. 3, 3 7. So it would be 3.6. And the area is changing. So it would be cm square per second. Let's take next question. The length x of a rectangle is decreasing at the rate of 3 centimeter per minute. Suppose we are given a rectangle, length is x and width is y. So here it's given dx upon dt. Decreasing means we have to write negative sign, minus 3 cm per minute. And the width y is increasing at the rate of 2 centimeter per minute. That is dy by dt is equal to 2 cm per minute. x is 10, y is 6. Find the rates of change of the perimeter. So perimeter P will be equal to twice of x plus 5. So if we differentiate it with respect to time, so dp upon dt will be twice of dx upon dt plus dy upon dt. Now we can put the values to dx upon dt is minus 3 and plus dy by dt is 2. So from here we get minus 2 and the unit will be cm per minute. Now here the perimeter in rate of change of perimeter we have evaluated. Now rate of change of area of the rectangle. So area of rectangle is given as x by length into breadth. So dA upon dt will be product rule can be applied here, x dy by dt plus y into dx by dt. Now, if we put the values, x is given as 10. So 10 times dy by dt, that is 2, plus y is given as 6 into dx by dt is given as minus 3. So it is 20 minus 18, that is 2, and the area, that is cm square per second. Let's see next question. A balloon which always remains spherical has a variable radius. Find the rate at which its volume is increasing with the radius when the latter is 10 centimeter. So balloon is here, and here a balloon which always remains spherical has a variable radius. Find the rate at which the volume is increasing. So we have to consider volume of sphere, that is 4 by 3 pi r cube. And here the rate is to be found with respect to radius. That is, we have to find out dv upon dr. So we differentiate it. So differentiation of r cube will become 3r square. So 4 by 3 pi into 3r square. So 3 will cancel out. And here r is given as 10. So 4 pi into 10 square, that is 400 pi, and unit will be just cm square because volume has unit cm cube and the radius has unit cm, so 1 cm will cancel out. Now let's consider next question. A ladder 5 meter long is leaning against a wall. So this is wall and this is ladder. This is 5 meter leaning against a wall. The bottom of the ladder is pulled along the ground. Bottom is being pulled in this direction, then top will come downward. So away from the wall at the rate of 2 centimeter per second. How fast is the height of the wall decreasing? So suppose this is x, this is y. So we are given dx upon dt as 2 centimeter per second. We have to find out dy by dt. Now this is right angle triangle. We apply Pythagoras theorem, x square plus y square equal to 25. We differentiate it, 2x dx by dt plus 2y dy by dt equal to 0. Now here it is given that when the foot of the ladder is 4 meter away, x is 4. When x is 4, so from here y will be 3. So we put these values and we have to find out dy by dt. So twice of x, x is 4, and dx upon dt is given as 2 plus twice of y, y is 3, dy upon dt is to be found equal to 0. So here 2 will cancel out, then this will be 8 by 3. So we put this value 2 into y. So 2 and the y is 3. So, and here 2 into x. So here I put double value. No, sorry. So 1 minute. Verify 2, and then x is given as 4, and then dx upon dt is given as 2. So, and when we divide it by 2, so 2 will cancel out. So we write it dy by dt equal to, this will become minus 8 and divided by 3, and the unit will be cm per second. Now let's consider question number 5. A particle moves along the curve 6y equal to x cubed plus 2. Now find the points on the curve at which the y coordinate is changing 8 times as fast as x coordinates. It means dy by dx, sorry, not dy by dx, but dy by dt equal to 8 times dxy. Now let's differentiate this equation. 6 dy by dt equal to 3x square dx by dt, and differentiation up to will be 0. So now we put this value, dy by dt is 8 times dx by dt. 6 into 8 dx by dt equal to 3x square dx by dt. So dx by dt will cancel out, and 3. So x square equal to 16, from where we get x equals plus minus 4. Now we try to get value of y from here. So when x equal to 4, then 6y equal to 4 cube plus 2, that is 66. So y equal to 66 divided by 6, which is 36. It will give 11. So we can write it 11. So first point will be 4 comma 11. Now let's consider next point when x equal to minus 4. So when x equal to minus 4, then from this equation 6 times y, that is 6y equal to minus 4 cube plus 2. So minus 64 plus 2, minus 62. So 6y equal to minus 62. Y equal to minus 62 upon 6. That will give minus y equal to minus 31 upon 3. So second point will be minus 4. So second point will be, suppose we denote it as d. So it will be minus 4, and corresponding value of y, that is minus 31 upon 3, which is our answer. Thank you for watching.